Yes. So we solved half of the question in the last class, and now we have to simply determine the value of x. So how can we find the value of x now? The value of x, it actually represents the ratio of moles of water to moles of calcium nitrate. So it actually gives you the ratio between the moles of water and the moles of calcium nitrate, like between the moles of water and the moles of, you can say, the salt which will be given to you, any salt. It it's always the ratio between these two things. So to find x, what we will do, we will simply find the ratio of moles of water, H2O, divided by moles of the salt which will be given in the question. So moles of water, they were already given in the question, and 0.06, 0.0600, and we calculated the moles of salt and they were 0.0150, 0.0150, and when we divide them, we get x is equals to 4. So it would be 4. The value for x, it would be 4. It means that calcium nitrate, it consists of 4 water molecules. Is it clear?
Yes, Miss, it's clear.
Okay. Then you're given that nitrates that decompose on heating. Write the chemical equation for the reaction when solid sodium nitrate is heated. You have to write the chemical equation for it.
Uh, when sodium nitrate is heated,
Yes.
it will
What's the chemical
be
formula for sodium nitrate?
it will, in 3.
NaNO3. Yes, very good. It's NaNO3. Yes. What happens when solid sodium nitrate is heated?
It will be like breaks down, so like the nitrate ion will lose oxygen.
So that,
The nitrate ion will lose the oxygen.
yes, very good. It actually undergoes a decomposition reaction.
Decomposition.
Yes. So what would be the products?
NaNO2 plus O2.
Very good, excellent.
Hmm.
So when we have sodium nitrate, it gets broken down into sodium nitrite and oxygen gas. This is sodium nitrate, which is NaNO3, and when we heat it, it gets converted into NaNO2, which is sodium nitrite, and oxygen will be released. Is it a balanced equation?
No, not really. No, there will be two, two, two sodium
Two
nitrate
sodium
and then two sodium nitrate and the
nitrite.
products nitrate
Yes, and what about the state symbols?
will be solid gas.
Very good. It's solid, solid and gas. Which type of reaction is this?
Thermal decomposition.
Very good, excellent. This is a thermal decomposition. Okay. Just a minute. Okay, so like, would you like to discuss the MCQs or the subjective part?
I would do MCQs because I get a bit confused now. More confused.
Okay, that's fine. Mm, okay, so these are about the preparation of salts. Okay, so we are given that group 1 metals form compounds with group 7 halogens. The compounds formed are dash in water and contain dash bonds. Which words correctly complete the gaps 1 and 2? The compounds formed are dash. Are they soluble or insoluble? We have two options for gap 1. Group 1 metals, they form the compounds with group 7 halogens. The compounds formed are soluble or insoluble.
So the compounds formed will
Yes.
be like
Group 1 metals
it will
include,
be soluble. The
very
compounds are
good,
soluble in water and contain ionic
very good, and contain which type of bonding?
ionic.
Group 1 contain metals and group 7 contains non-metals.
So
So which
B,
bonding actually exists between them? Between metals and
D,
non-metals?
D.
Very good. It's soluble and ionic. It's D. Okay, which pair of substances can be used to prepare a sample of lead chloride when added to water and mixed? Which pair of substances can be used to prepare a sample of lead chloride?
Which is contain water mix.
Is lead chloride soluble or insoluble?
Lead chloride is insoluble.
Very good. So which of these pairs gives us lead chloride?
Lead to nitrate and sodium chloride.
Lead to nitrate and sodium chloride. Very good, excellent. It's option B. Why not option A?
Minus,
Why
sorry.
not lead? Why not option A? Lead and sodium chloride.
Because the lead metal does not react with sodium chloride solution. Lead.
Very good, excellent. Very good. And why not C? Lead carbonate and sodium chloride.
Lead carbonate and sodium chloride. It's
Yes,
because like the lead carbonate is insoluble in water.
very good. Because to create the lead chloride, we need to mix two soluble salts solutions together.
Okay.
We get an insoluble salt from two soluble salts, right? But lead carbonate, it is insoluble in water. And what about option D? Lead and hydrochloric acid.
Lead and hydrochloric acid. It's
Yes.
because lead is low reactivity metal, so it will like
Uh,
react very slow with hydrochloric acid.
yes. The reason is the same that we discussed before. Like lead reacts very slowly because a coating of insoluble lead chloride will form on the metal and it will stop the reaction. So option B is the correct option. Lead nitrate and sodium chloride, they are both soluble. And when they mix together, which type of reaction takes place to give us lead chloride?
And that is
Yes, which type of reaction takes place?
Could you scroll down the options?
The
I,
options?
I can't see the options for question 3.
No, like I am
Okay.
asking you it on my own. This is not written on the screen
Oh,
anywhere.
okay. Right, right,
Yeah,
okay.
I'm just
Yes,
saying that lead nitrate and sodium chloride, they are both soluble salts. And when we mix them, we get lead chloride, right?
yes.
So when we mix them, which type of reaction does take place that give you lead chloride? Which type of reaction?
Like that night, the reaction is like a displacement reaction,
Very good. It's a double displacement reaction. Very good.
double displacement.
Okay. The table, it shows the result of two reactions of an aqueous solution of a salt. Reagents are excess aqueous sodium hydroxide, and observation is white precipitate, and the second one is dilute nitric acid and aqueous silver nitrate, and the observation is yellow precipitate. What is the name of the salt?
Mm, mm,
Using the first row, like the reagent where it's excess aqueous sodium hydroxide and the observation is white precipitate, what can we identify using this information?
we can, mm, it can be, this
You can
is,
identify the
yes,
cation that will be present in the salt, right?
oh,
So
yes,
which cations can react with sodium hydroxide?
sodium, mm,
What about calcium ions?
calcium,
If I
um,
have calcium ions, will they
yes,
react with sodium hydroxide?
it will like, will like calcium react, yes.
Yes, calcium ions, they react with sodium hydroxide and they gives us a white precipitate of calcium hydroxide.
Mm,
What other possibilities do we have other than calcium?
mm,
What about
can it
zinc
be,
ions?
yes, zinc
Zinc,
ions can also like, yeah,
yes, zinc ions, they can also react with sodium hydroxide and they also form a white precipitate of zinc hydroxide. So which one will be the correct option? Calcium ions or the zinc ions?
it will be,
Yes.
mm, calcium.
What's the reason?
Because like from the sodium hydroxide it cannot like dissolve in excess.
Very good, excellent. Because calcium hydroxide, it does not dissolve, it remains even when excess sodium hydroxide is added. And as far as the zinc hydroxide is concerned, it is amphoteric in nature and it dissolves in excess sodium hydroxide to form a colorless solution. So the cation must be a calcium cation because we are observing a white precipitate. So we should have that precipitate which does not get dissolved in excess of sodium hydroxide. So the cation must be a calcium, Ca2 plus. And what about the anions? Now, if we want to identify the anions, we are given the options. As far as the cations were concerned, we can see in the options that we had only two possibilities. The first one was calcium and the other one was zinc. How can we now identify the anions, the negative ions?
We can like
We are given the second result that dilute nitric acid and aqueous silver nitrate gives us yellow precipitate.
oh okay. The iodide
Iodide, very good, excellent. And how do we know that?
like like iodide is yellow precipitate.
Very good. Iodide ions, they forms a yellow precipitate. What about chloride ions?
They form chloride. They form white.
Very good. Chloride, they form white. Okay. What about um iodide? They are yellow.
Iodide. Yes.
What about bromide?
Bromide is cream.
It's green or cream?
Cream.
Yes, it's cream. Very good. Okay, so the correct option would be option B. It's calcium iodide. Which substance? It's insoluble in water. Ammonium carbonate, ammonium nitrate, calcium carbonate, or calcium nitrate.
It is insoluble.
Which of these is insoluble in water?
It is
And ammonium nitrate, are they
what
soluble
is
or
it?
insoluble?
Calcium carbonate.
Very good. It's calcium carbonate. Why not A and B? Because all the ammonium salts they are soluble. And why not D?
Because the nitrate, all nitrate.
Salts are also soluble in water. Very good. And what about carbonates? Are all the carbonates insoluble?
No,
No.
no, not all.
What are the exceptions?
Sodium, potassium, and ammonium.
Very good. Most of the carbonates they are insoluble except for the ones that belong to that contain the group 1 elements like sodium or potassium. Okay, very good. Which process is used in the preparation of soluble salts? Electrolysis, evaporation, melting, or precipitation?
Evaporation.
Yes, very good. It's evaporation. Okay, then we are given ethyl, amine gas, and hydrogen chloride gas. They react together to form a white solid, ethylamine hydrochloride. At which position in the tube would a ring of solid white ethylamine hydrochloride form? A, B, C, or D? You are given the options as positions. Cotton wool soaked in ethylamine solution and cotton wool soaked in hydrochloric acid.
Mm,
This one is, I guess, also not a part of your syllabus. Like, have you learned the Gram's law of diffusion?
no, no.
So, yes, this is not a part of our syllabus. So, what is the correct sequence of for obtaining the pure salt from a mixture of sand and salt? How can we obtain the
Obtain
pure
pure
salt?
salt.
Yes,
We add like water, filter, and then evaporate it.
very good. So, it's option C.
Mm.
Okay, so to which substance is dilute sulfuric acid added to prepare the lead sulfate?
Dilute sulfuric acid.
Added to prepare lead sulfate.
Lead to sulfate. Aqueous led to nitrate.
Aqueous led to nitrate. Option A. Very good, excellent. The table shows the solubility of some common compounds of metal Q in cold water. The carbonate salt of that metal Q, it is insoluble in cold water. The chloride salt of that metal Q, it is soluble in cold water. The sulfate salt of that metal Q, it is also insoluble in cold water. What is that metal Q? Is it barium, lead, magnesium, or sodium? You can evaluate the options one by one. What about barium carbonate? When if the metal is, let's say, barium, is barium carbonate insoluble?
Barium. I was muted. I was saying the answer is barium.
Yes, very good. Because barium carbonate it's insoluble, barium chloride is soluble, and barium sulfate is also insoluble.
Insoluble.
What about lead? Is
Lead
lead
is
carbonate insoluble?
lead carbonate is insoluble.
Very good. What about lead chloride?
It's insoluble.
Very good. So it's not correct according to the table.
Yeah.
Okay, moving to magnesium. Is magnesium carbonate insoluble?
Magnesium is insoluble. Yes.
Magnesium chloride?
Chloride is soluble.
Very good. What about magnesium sulfate?
Magnesium sulfate is soluble.
Very good, excellent. So this cannot be the option. And what about sodium?
Sodium carbonate is soluble.
Yes,
And then the chloride is chloride is also soluble.
yes. What about sulfate?
Sulfate is also soluble.
Yes, all common sodium salts they are soluble. Okay. Then we are given an aqueous solution of a compound X. It reacts with the aqueous zinc chloride to form a white precipitate which dissolves when X is in excess, and aluminium sulfate solution to form a white precipitate which is insoluble when X is in excess. What is the identity of X? Ammonia, barium chloride, silver nitrate, or sodium hydroxide?
Identity of X is
X reacts with aqueous zinc chloride to form a white precipitate which dissolves when X is in excess.
it ammonia is it a ammonia?
Option A, ammonia. Very good. What's very good, excellent. And what's the reason? Like,
Because uh,
yes,
zinc forms like white precipitate that dissolves in excess with ammonia,
okay,
and then the white like it is like insoluble.
yes,
Then excess ammonia.
okay, very good, excellent. It's ammonia. Option A. Which reagent is added to aqueous potassium chloride to prepare lead chloride?
Again, chloride, lead chloride, Uh, aqueous lead nitrate.
Which one?
A. Aqueous lead nitrate.
Very good. And why are option B, C, and D not correct?
Because they're all insoluble, and they do not work with precipitation.
Very good, excellent. Which compound is insoluble in water? Lead sulfate, silver nitrate, sodium carbonate, or zinc chloride? Which of them is insoluble in water?
Lead nitrate. Lead sulfate.
Yes, it's lead sulfate. Very good. Silver nitrate, is it soluble? Yes,
Silver
because
nitrate is soluble. Yes.
all
All
nitrates
nitrates
are
are
soluble.
soluble.
What about sodium carbonate?
Yes.
Why is it soluble? Are all the carbonates soluble? No. Then
No.
why is this soluble?
Because group one metal.
Yes, very good. It consists of a group 1 metal. What about zinc chloride?
Zinc chloride is soluble.
Are all the chlorides soluble?
No.
What are the exceptions?
Silver
Yes,
and lead chloride.
very good. Very good. Excellent. Silver and lead are the exceptions. Other than this, all the chlorides are soluble. Okay, then we are given that salts containing which of the following anions are always soluble in water? Carbonates, chlorides, nitrates, or sulfates?
Always soluble in water.
Yes,
Of the nitrates.
very good. Excellent. It's all the nitrates. In others, we have exceptions, but nitrates are all soluble. Which acid and base react together to produce an insoluble salt?
Acid and base
Hydrochloric acid and sodium hydroxide, nitric acid and calcium oxide, sulfuric acid and barium hydroxide, or sulfuric acid and zinc oxide.
the C. Sulfuric acid and barium. No. Yes, sulfuric acid and barium hydroxide.
Very good, excellent. Which salt will we get when we react sulfuric acid and barium hydroxide?
We get barium sulfate.
Very good, which is insoluble. What will we get when we react hydrochloric acid and sodium hydroxide?
We get sodium chloride.
Very good, and it's highly soluble. What do
Hmm.
we get when we react nitric acid and calcium oxide?
Calcium nitrate.
Very good, excellent. And we know that all the nitrates are soluble, so it will also give you a soluble salt. What do we get when we react sulfuric acid and zinc oxide?
Zinc sulfate.
Very good. And zinc sulfate, it is also a soluble salt. So the correct option is option C. Okay. Then we are given that which substance would not be used for preparing a pure sample of crystalline magnesium sulfate by reaction with dilute sulfuric acid? Magnesium carbonate, magnesium hydroxide, magnesium nitrate, or magnesium oxide? Would not be used for preparing a pure sample of crystalline magnesium sulfate by reaction with dilute sulfuric acid.
Not be correct for proof. It is magnesium nitrate.
Option C. Very
Yeah.
good, excellent. It's magnesium nitrate. And what is the reason?
Because you like to prepare a pure sample of the salt, like the like soluble salt,
Yes,
you react an acid with a solid base.
very good. Okay, so it's option C. Then we are
Mm.
given which pair of the compounds could be used in the preparation of calcium sulfate.
Mm,
Calcium carbonate. And sodium sulfate, calcium chloride, and ammonium sulfate, calcium hydroxide and barium sulfate, and calcium nitrate and lead sulfate.
Is it calcium chloride and ammonium sulfate?
Very good, excellent. It's calcium chloride and ammonium sulfate. And why are other options not correct? A,
Because
C,
they're like
D.
calcium carbonate, calcium is carbonate is like insoluble, so insoluble.
Very, very
And for
good,
B, calcium chloride is like an ammonium sulfate. It's like they all are soluble.
very good,
And then C is like the barium sulfate is insoluble.
very good.
And
Calcium
for
sulfate. Yes, we know that calcium sulfate is an insoluble salt, and to prepare an insoluble salt, we require two soluble salt solutions. But in all the other three options, one of the compound it is insoluble. Only option B is the correct option, which contains both the soluble compounds or the soluble solutions. Okay, then we are given that a student mixed together aqueous solutions of Y and C, a white precipitate formed, which could not be solutions Y and C. Solution Y, which could not be solutions Y and C. Solution Y is hydrochloric acid and sodium chloride, and Z is silver nitrate, sodium nitrate, lead nitrate, and silver nitrate again. A student mixed together the aqueous solutions of Y and
yes,
C, a white precipitate formed. So we actually want to see, what do we want to see? That by reacting each pair, which pair will not give you a white precipitate?
it
Which
will be
would not be the solution Y and C? So we simply want to see that which pair won't give you a white precipitate.
white precipitate. Okay.
Yes.
The um will be hydrochloric acid and sodium nitrate.
Very good, excellent. It's option B. What do we get when we react hydrochloric acid with silver nitrate?
Hydrochloric acid, silver. You get like silver chloride.
Very good. And it is a white precipitate.
Okay.
What do we get when we react sodium chloride and lead nitrate?
Sodium chloride
And lead
and lead
nitrate.
nitrate will get lead chloride.
Very good. And it is also a white precipitate. And what do we get when we react sodium chloride and silver nitrate?
Silver chloride.
And it is also a white precipitate.
White precipitate. Yes.
Very good. And what do we get when we react hydrochloric acid and sodium nitrate?
Hydrochloric acid and sodium nitrate will get sodium chloride.
Very good. And we know that all the nitrates and all the sodium salts, they
Sodium
are
chloride
soluble.
insoluble.
Very good. Okay, moving forward, which metal has a soluble carbonate, chloride, and sulfate? Which metal has all of these three salts soluble?
Potassium.
Very good, potassium. Okay, which among the carbonates, chlorides, and sulfates, which of these is insoluble for barium?
Barium for barium is like for sulfate.
Yes, barium sulfate and barium carbonate.
Carbonate.
They
Yes.
are both insoluble. What about calcium?
Calcium sulfate and carbonate.
Very good. What about copper?
Copper. Copper is like the
Which salt of copper is insoluble?
salt of copper is
Insoluble. Is it
or like
copper
all of them?
carbonate, chloride, or sulfate? It's copper
All?
carbonate. Copper carbonate, which is insoluble. Okay, then moving forward, we are given that solid Y, it is insoluble in water, it gives off a gas when heated and also when reacted with dilute sulfuric acid. What is Y? Copper carbonate, sodium carbonate, sodium nitrate, and or zinc oxide.
Why is insoluble? Why is
Solid Y
insoluble in
is
water?
insoluble.
Copper to carbonate?
Option A.
Yes.
Very good. It's copper carbonate. The first property that was given in the question, it was solid Y. It is insoluble in water. So we know that sodium carbonate um, and yes, we know that sodium carbonate and sodium nitrate, they are both soluble in water. So option B and C are already eliminated according to the first property that is given. Then we had to decide between zinc oxide and copper carbonate. So how did you find out that it's copper carbonate, not zinc oxide?
Why not zinc oxide?
Yes. B
It's
and C are
yes,
already eliminated, right?
already
According to
yes.
this property.
Bec-
Why
zinc
not?
oxide is insoluble in water.
Zinc oxide is?
Insoluble in water. And it says
Yes.
what is
So
yes,
solid Y is also insoluble in
yes.
water. So then
But
how did you find out that it's not zinc oxide and copper, it's
because
copper carbonate?
because like because copper carbonate, it reacts, it produces salt water and carbon dioxide, and zinc it's like reacted acid to produce salt and water only.
Very good. Because there was a property too which said that the metal gives off a the compound, it gives off a gas when it is heated. So we know zinc oxide, it only produces a salt and water. No gas will be produced. But as far as copper carbonate is concerned, whenever the carbonates they react with the acids, they give us the carbon dioxide gas. So we use both of the properties, property 1 and property 2, to get to the actual solution. Then we are given that which salts are soluble in water: ammonium carbonate, calcium carbonate, lead carbonate, and sodium carbonate. Which salts are soluble in water?
Which soluble
Yes. Is ammonium
soluble
carbonate soluble or insoluble?
ammonium carbonate is soluble,
Very good. What about calcium carbonate?
insoluble,
Very good. What about lead carbonate
insoluble.
and sodium carbonate?
Sodium carbonate, it is soluble.
Very good. All the ammonium, sodium, and potassium salts, they are all soluble. So option A and 4 are the correct options. The correct option is option C.
Okay.
Okay. In which reaction do the products formed not include a salt? Calcium carbonate with hydrochloric acid, copper oxide with hydrogen, copper oxide with sulfuric acid, or copper sulfate with sodium hydroxide. Which of these reactions do not produce a salt?
Which of these carbonates do not include a salt?
Yes, which of these won't produce a salt?
Calcium. Precipitation method.
What do we get when
B.
we
Copper oxide with hydrogen.
very good excellent? What would be the products?
It would be like pure copper metal and water.
Very good. Very good. There will be no salt formed. In all the other options, we will get a salt. Okay, which salt can be prepared by an acid alkali titration method? Ammonium sulfate, copper sulfate, iron sulfate, or zinc sulfate?
Which solvent with the acid alkali
Yes,
titration method. Mm, it, it can be ammonium sulfate
very good,
because
excellent. Because
it's made from like sulfuric acid and nitric ammonia.
yes, very good. Titration method it is specifically used to prepare the soluble salts from soluble starting materials. So it would be ammonium sulfate. Okay. And why not the other ones? Copper sulfate, iron sulfate, and zinc sulfate?
Because they are like soluble. They're like soluble salts. So like they're like
Titration is
reactive.
yes. They are actually formed from the materials among which like at least one of them is insoluble. But titration it is mostly specifically used for preparing the soluble salts from the soluble starting materials or soluble reactants, you can say. But in copper sulfate, what do we require to prepare copper sulfate? It is
Required
usually
to make
prepared by reacting, yes, copper sulfate.
like whatever like they're what is it used to prepare
Yes,
by
like like if I want to
using
prepare copper sulfate, which two reactants can I use to prepare copper sulfate? It can be usually
or two
prepared by reacting
reactants
the sulfuric acid with, yes, what would be the starting materials?
starting materials it would be like it would be like uh,
You can use the sulfuric
zinc,
acid with copper
iron and
oxide or
copper
copper
sulfate.
carbonate.
Okay.
Yes. And
It would be like iron and copper sulfate.
very good. And the bases they are insoluble solids. So which method will we use? The excess base method will be used,
Sulfate.
not titration method. What about iron sulfate?
Like two reactants.
Yeah. Will it consist of any insoluble starting material as well to prepare the
It would
iron
be like
sulfate?
iron sulfate plus sodium hydroxide.
E-
Uh,
Iron, yes, it will be prepared by reacting the iron metal or iron oxide, which is
yes.
insoluble, with sulfuric acid. And what about zinc sulfate?
It can
It's
be like zinc with
it's
uh,
prepared by the reaction of sulfuric acid with zinc metal or zinc oxide, which is
zinc
also
metal.
insoluble.
Yes.
But titration it is used to prepare the soluble salts that are formed from the soluble starting materials. That's why option B, C, and D are not correct. Okay, then we are given that the table shows the properties of four chlorides, which is magnesium chloride. You're given the color, you're given the solubility in water, and the method of preparation as well. Which of these is magnesium chloride?
This is magnesium chloride. Can
Yes.
be
What do you know about the solubility in water?
solubility in water. It's
Yes.
it's like the maximum amount of solute that dissolves in like the amount of water.
No, like, is magnesium chloride soluble or insoluble? This is what I'm asking.
Oh,
That
okay.
want to see which of these is magnesium chloride.
Magnesium,
So,
it is soluble in water.
if we want to narrow down the options, which options will be eliminated?
Mm,
Is it soluble or insoluble?
soluble. So B and D eliminated.
Very good. B and D are already eliminated. B and D. Now you have to only decide between option A and C. We are given the method of preparation and the color. The method of preparation is the same. It's metal and
Mm.
acid. We are only left with the color.
So C,
Yes, why not A?
because like the magnesium is it's like group one and two metals are typically white solids.
Very good, very good. Because group 1 and group 2 metal salts, they form the solid, white solids, not green. Option C is the correct option.
Okay.
So, in any such question where you get confused between the options and you don't know what's the correct option, you can first eliminate the options for like about which you are sure that this cannot be the option. Then at the
Okay.
end, you can decide by downing your options. Okay, so which pair of substances they react to form a salt and water only? Sodium chloride solution and silver nitrate solution, sodium hydroxide solution and dilute ethanoic acid, sodium carbonate solution and dilute sulfuric acid, and zinc and dilute hydrochloric acid
Form a salt and water, sodium
only.
chloride and sulfur nitrate, and dilute it with salt and water only. B, sodium hydroxide and dilute ethanol acid.
Very good. Because we know that we get salt and water only in the neutralization reactions only.
Mm.
Option B is a neutralization reaction. It has one base and one acid. So it will give us only a salt and water. Okay, then we are given the table gives information about the solubilities of the hydroxides, carbonates, and sulfates of calcium, sodium, and zinc. What is the best way of making zinc carbonate? Shake the aqueous zinc sulfate with aqueous sodium carbonate. Shake aqueous zinc sulfate with sodium calcium hydroxide and bubble in carbon dioxide. Shake the solid zinc hydroxide with aqueous sodium hydroxide and bubble in carbon dioxide. Shake the solid zinc sulfate and solid calcium carbonate with water.
Mm, the same making carbonate can be six aqueous. A, shake aqueous zinc sulfate.
Very good, excellent. It's option A. And how did you find the correct option?
Because to perform precipitation, it's like reaction, they must be two soluble solutions together.
Yes, two soluble solutions are mixed together and we get zinc carbonate, which is an insoluble s- solution. Why not B and C or D?
Why not B, C, and D? It's
Yes,
because it's because like the idea you have to find the sodium. So B is with
yes,
calcium hydroxide.
yes. Why not
Yeah,
B and C and D?
with calcium hydroxide. Calcium hydroxide is mm, mm, it's because
Yes,
uh, they're like the insoluble salt and like the zinc carbonate is like the precipitation method. Like B is incorrect because like
yes.
we are starting with a solid calcium hydroxide.
Very good.
And then C is incorrect because we are starting with sodium, solid zinc,
Yes, and
sodium
why D?
hydroxide. Yes. And
And why
D,
D?
D is like calcium carbonate is insoluble.
Very good, excellent. Okay, then we are given the equation for one method of making the copper carbonate is shown below. The reaction is an example of neutralization, oxidation and reduction, preparation or synthesis.
So copper carbonate sodium carbonate. Precipitation.
Very good, excellent. This is precipitation because we are reacting to soluble solutions to get a insoluble solid. Okay, then we are given rubidium is in group 1 of the periodic table. What are the properties of rubidium chloride? You're given the formula and approximate melting point and the solubility in water.
Maximum density is of rubidium chloride.
Yes,
Uh,
but do we know about the solubility?
it's soluble.
It's soluble. Group 1 metal salts, they are generally soluble in water. So option A and D cannot be the correct option. What
B,
about B and C?
B,
B, very good. Why not C?
the formula.
Very good. Because it belongs to group 1, so its valence is positive 1. And chloride also has the charge negative 1, so that as a whole, it can give you a zero charge. So it would be B. Which substance reacts with water to form a soluble compound and an insoluble gas? With ammonium sulfate, cesium, calcium carbonate, or copper?
What's cesium?
It's
Mm,
also a element, obviously.
okay,
This is a reactive alkali metal. Cesium is a reactive alkali metal.
okay.
And when it
Mm,
reacts with water, it forms cesium hydroxide.
okay.
Cesium, it is the correct option is actually cesium. When it
Okay.
reacts with water, it forms a very strong base, which is cesium hydroxide, and hydrogen gas will also be released. So if we have cesium, which is Cs, you react it with water, you will get cesium hydroxide and hydrogen gas will be released. And it is cesium hydroxide, it is a strong soluble base. This S is small, it's written
Okay.
like this, Cs. So this is a strong soluble base. So which substance reacts with water to form a soluble compound and in an insoluble gas? The hydrogen gas that will be released, it is insoluble in water, and that's why it escapes as bubbles, because this is insoluble. So the correct option will be cesium. Okay. And this cesium, it is a highly reactive alkali metal. Okay, moving forward, we are given which pair of substances produce a precipitate when their aqueous solutions are mixed. Sodium chloride and barium nitrate, sodium nitrate and barium chloride, sodium nitrate and silver nitrate, or sodium sulfate and barium chloride. Which of the pair produces a precipitate?
Precipitate. Mm, insoluble. BD, barium sulfate.
Sodium sulfate and barium chloride.
Yes,
What would be the products that we will get?
barium sulfate.
Very good. So option D. Okay, then we are given that which two reagents could be used to prepare the insoluble salt copper carbonate.
Which two reagents can be used to prepare
The insoluble
insoluble
salt copper carbonate.
copper carbonate solution? Mm,
Prepare an insoluble salt, we again need to mix two soluble salts. So which of these is the correct option? In option A,
sodium
we have
carbonate.
which one?
Is it C?
Option C, very good. Because in option A, we need two soluble starting materials.
Yes.
But over here, this copper oxide, it is insoluble. In option D, magnesium carbonate is insoluble. And why not B?
B is because like
Them are
two
in.
solids.
Yes, because both of them are insoluble. Only option C is the correct option. Okay, then we are given which method of preparation of a pure salt solution requires the use of a pipette and burette. Which of these?
Put on a burette. Mm,
When do we use pipette and burette?
two like reacting solutions.
Yes, but in which type of reactions?
Alkali,
Which
aqueous,
method? Very good. In which method? When we are preparing using the titration method.
titration.
Yes. Which of these involve
C,
the preparation using the titration? Option
potassium.
C. Very good.
C.
Excellent. It's C. Why not A?
Because potassium, why not?
Why not A? Because this is a precipitation reaction.
It's, then, okay.
Yes, we use titration
It's
method.
because
Wh-
it
Yes,
describes as a precipitation. Like the barium chloride and sulfuric acid, it will form barium sulfate.
yes.
So it's
So
insoluble. So
very
it will
good.
be like precipitation
Yes,
method.
very good. Why not B? Because this method it uses an excess insoluble
Excess
base method.
insoluble.
Yes,
Yes,
option C is the correct option, and why not D? Because it requires excess insoluble carbonate
excess
method. Okay, then we are given that which reactants could be used safely to prepare potassium chloride. aqueous potassium hydroxide and dilute hydrochloric acid, aqueous potassium sulfate and aqueous sodium chloride, potassium and aqueous sodium chloride, or potassium and dilute hydrochloric acid.
Safely prepare potassium chloride. Mm, mm,
Yes,
it's A. Is it A? Because aqueous.
very good. It's A. Okay, excellent. And okay, in an experiment, 5 centimeter cube of 1 mole per decimeter cube sodium hydroxide they are gradually added to 10 centimeter cube of 1 mole hydrochloric acid containing methyl orange, which change occurs in the mixture. The concentration of the H plus ions increases, the methyl orange color changes, more water molecules are formed, or a precipitate is formed. What would be the change?
Change is more water molecules are formed.
Very good, excellent. It would be
Neutralization reaction.
very good, excellent. This is a neutralization reaction, so more water molecules will be formed. Okay, then we are given that salts are made by reacting the acids with bases. For which combination of acids and bases is the titration method of preparation suitable? An insoluble acid with an insoluble base, an insoluble acid with a soluble base, a soluble acid with an insoluble base, a soluble acid with a soluble base.
So which combination of acid bases better? Titration a soluble acid with soluble base.
Option D, right?
Yes.
Very good, excellent. This is option D. And this is the last MCQ. And an acid X was added to a solution of the nitrate of metal Y. A dense white precipitate was formed. What are X and Y?
X is added to solution
Yes, what are
and X
X and Y?
sulfuric. Uh, sulfur- is it D? Sulfuric and barium.
Very good, excellent. This is sulfuric acid and barium. Option D. Yes, this is all. And how is the preparation? I can see it's really good.
It's
MashaAllah.
good. Alhamdulillah.
Yes. And best of luck for your exam.
Thank
And
you.
inshallah, it will be very, very good. You will perform
Inshallah.
really good. Just don't panic. This is the only thing that I will say. I
Okay.
know you have prepared very well. Just read the question carefully and don't panic. Like, read all the questions slowly, pay attention to the question, and you will do very good, inshallah.
Inshallah.
Okay, take care and best of luck. Allah Hafiz.
Thank you. Allah Hafiz.